Greetings, everyone. Today we're going to take a look at the Algebra and Functions section of the ACT. Let's start off with a few key terms that I know you'll easily remember, but they often get mixed up. Multiple versus factor. Remember that factors are what we can multiply to get a number. So take a look at the factors of 48. Multiples are what we get after multiplying the number by an integer. So for example, the multiples of 3 are as follows. The key difference that will help you remember this is factors are limited. There's only so many factors of 48, but multiples keep going because I can keep keep adding on 3 every time. Don't forget what a prime number is. A number greater than 1 whose only two whole number factors are 1 in itself. Here's the first few prime numbers to refresh your memory. Let's take a quick review of proportions. Proportions are often written with a colon. In order to make this easier to work with, we typically rewrite them as fractions, because as we know very recently, when we have a fraction equal to a fraction, we can cross multiply. If you'd like to review this example, you'll want to pause the video now and take a look. Proportions on the ACT are also often written as word problems. For example, if a snowstorm dumped 18 inches of snow in 12 hours, how many inches were falling per hour? You want to read the word problem in order and fraction equal to fraction. 18 inches in 12 hours equals how many inches in 1 hour? Then we can cross multiply and solve. Exponents will also show up on the ACT. We've recently created our foldable and use that to help us with the rules of exponents. Make sure you spend time reviewing those rules and any of the activities that we've done in class. Let's briefly recall scientific notation. Remember that if you have a very large number, for example, the one provided, make note of where the decimal is. Typically, when we learn scientific notation, we then counted how many spaces until we would get to the first number. That becomes my decimal, and then the amount of spaces we moved becomes my exponent. Another quick algebra review is the division of polynomials. Whether you choose to use long or synthetic division, you will probably encounter a division problem. If you'd like to explore this particular example, pause the video. Or if you would like to explore it using synthetic, take a moment to write that down. Let's recall different ways to solve equations. One of the ways is using substitution. When given two equations, whether it be very literal as I have here or presented in a word problem. For substitution, you want to take one of the equations and solve for a variable. So for example, we're going to take this first example and solve for y. Meaning, just add the 3x over and you will get y equals. Because it's y equals, we can then take that equation and plug it in for y into the second equation. We're substituting it in to the second equation. Once it's substituted in, as you can see here, then we can just simplify. Follow your order of operations, get x by itself. Once you have x by itself, take that value, plug it into either equation, and solve for y. Your solutions are often written as point values, so make sure that you make note of which one is the x and which one is the y value. Another way to solve equations is using the elimination method. The elimination stands for eliminating one of the variables. So provided these two equations, if I want to get rid of the x values, they need to be opposite, which means I have to take that first equation times 4. Once I do that, I line them up, and when I add the equations, the x's go away. That makes it very easy to get y by itself. Similar to substitution, once you have one letter, you want to go back to substitution and just plug it in to get your x value. Again, write your solution in point form. Feel free to pause the video and write this equation down and try it for yourself. Let's review absolute value equations. When you have an absolute value, you have to solve it twice. Once, you're going to write it just as is. Nothing changes in the first solving step. But in the second step, you want to convert one side to negative. Once you've distributed that negative, just solve as you normally would. Here's the great thing about solving using substitution, elimination, or in absolute values. You can check all of your answers. Plug it in. 5 plus 2? Yeah, that's 7. Negative 9 plus 2 is negative 7. But if I take the absolute value, I arrive back at 7. Also note, if this is on the ACT, it's a multiple choice. So if you get stuck, you could take the A, B, C, D, E options and try plugging them in to see which ones work. One way might take a little longer than the other, but do what works best for you. Let's talk about inequalities. Similar to equations, you've got an expression and a value, but instead of an equal sign, here we have a less than sign. Let's just solve the same way we normally would. I'm multiplying by 2, so I'm going to divide by 2. Then it became an absolute value in this one. So I'm combining inequalities and absolute values. So you can write it two ways. You can say 3x plus 9 is less than 18. That's writing it as is. You can also write it as 3x plus 9 with a negative 18, but this time you would have to flip the sign because you made a side negative. Solve that through and you'll end up with two x values. If you separate them, you might end up with x is less than 3 and x is greater than negative 9. Note that these mean the same thing, so you'll still arrive to the same solution. It's just if you want to separate them or keep it together. But again, to solve inequalities, follow the same steps you would if it was an equation. A couple very quick topics that won't take much time. Foiling. We have been foiling non-stop in class. So those will pop up on the ACT. Quick fix, FOIL it out. If you're familiar with the box method, you could also do that. Another quick refresher, we've been factoring non-stop since the beginning of the semester, and factoring will be on the ACT. So just recall those rules, use the AC method, and check your answers. Let's take a few minutes to recall basics about functions. The first key thing about functions are the input and output values. Just as it sounds, input is what you put in to the function, and output is the result. So, if I plug in an x value, what do I get for my y value? X would be my input, y is my output. Function notation. Function notation looks like f of x typically, or a different letter of x. Typically, we've been writing y equals x squared. f of x is just a clear way to identify what my input should be. Ordered pairs. Again, my input and output are often written as ordered pairs, meaning if I have 2, 3, 2 is my input, 3 is my output. Intercepts. Intercepts are on our coordinate plane. If it's x-intercepts, they're on the x-axis. If they're y-intercepts, they're on the y-axis. What's important to remember here is, if they're on the x-axis, their y value is 0, or their output is 0. If they're on the y-axis, their input is 0. So remember which one is 0 for your intercepts. Domain and range. Domain is related to your input. Range is related to your output. More simply put, graphically, domain is all of the possible x values, meaning on a graph, how far left to how far right does my graph go? Range is often related to your y values. How far up to how far down does a graph go? What are all the possible y values I could end up with? Vertical line test. When looking at a graph, we have a function if I can draw a vertical line and it only passes through the graph at 1 point. 1 point, 1 point, 1 point, 1 point. And I could do that over and over and over again. If I draw a vertical line and it goes through more than 1 point, that is not a function. So typically when we have our x squareds, x cubes, x to the 4th, or linear, those are functions, and we use them as functions. But graphically, if you see something that looks a little different, if it doesn't pass the vertical line test, it is not a function. We also have even and odd functions. We've talked a little bit about these in class. What is the highest exponent of a function? Or can I plug a negative value in for x and still get the same output? Those are just some of the basics about functions. If you have any very specific questions, definitely ask, and you can also Google these key terms and use the word function. Just a quick review. Remember that if you can't factor to find solutions, you're going to need to use the quadratic formula. Find one of those YouTube tunes to help you remember what it is. And maybe practice one to make sure you remember how to plug in your A, your B, and your C value. Also remember that when using the quadratic formula, you might end up with a complex number. A complex number involves imaginaries. Imaginaries result from trying to square root a negative number. So an example might look like 3 plus or minus 2i. These imaginaries would be results of using the quadratic formula. Not always, but sometimes. So just keep an eye out for that keyword. Complex just means, in general, that there might be an imaginary involved. Last quick review is talking about quadratic inequalities. To start off with a quadratic inequality, just treat it as a quadratic. You've got your function of 2x squared plus 4x minus 8. We can graph that no problem. If it is just less than, it's a dotted line. If it's less than, greater than, or equal to, it's a solid line. So this graph, you'll notice, has a dashed line. Then you have to decide which side you want to shade. I always use a test point. So here they use the test point of 0, 0. When they plugged in 0, they got zeros less than -8. That is not a true statement. Therefore, I don't want to shade 0, 0. I want to shade the opposite of 0, 0. These inequality graphs with shading can occur with quadratics and linear equations, which would take us back to some Algebra 1 review. Again, I know a lot of this was a very quick refresher. I just wanted to touch on little topics that you will see. Now you'll want to take some time to work on the Google form questions so that we know what to spend time on in class. Take your time, and we'll see you later.